You know, if you're deep in the world of embedded systems, doesn't matter if it's C++ for an STM32 or even a .NET app on an ESP32, your operating system is so much more than just a background utility. It's the literal foundation of your entire toolchain. And, well, if you're not using the right one, it's not just unhelpful, it's actively holding you and your code hostage. So let's get into why that is. So what's the core problem here? Why does so many of us feel like we're constantly fighting our own computers when we're on Windows or a Mac? I absolutely love this analogy, because it just hits the nail on the head, doesn't it? It feels clumsy. You don't have that fine-tuned precision you need. You spend all your energy just fighting with your tools instead of focusing on the actual intricate work of building firmware. Everything just feels, well, wrong. And look, this isn't just some vague feeling in the air. It translates into real, concrete frustrations that I'm sure you've felt. We're talking about painfully slow feedback loops from compiles that take forever, and hardware connections that are just so unpredictable. It feels like a constant battle just to get a stable link to your own device. Now, this slide right here, this is where it gets really interesting. Let's just imagine for a second you're tweaking a font on a little display and you've got like 40 different variations you want to test. A 15-minute recompile on Windows for every single change can literally be cut in half on Linux. We're talking about a 50% reduction in wasted time. That is a massive bottleneck, just gone from your workflow. Okay, so how does Linux actually solve these very specific problems? Let's just break it down into the 3 key advantages. We're talking speed, stability, and control. First up, speed. It's pretty simple, actually. Most of the embedded toolchains we use, like Espressif's ESP-IDF, they were built for Linux. They run natively. But on Windows, they're often running through these compatibility layers, which, you guessed it, add overhead and slow everything down. With Linux, there's no translation needed. It's just a direct, super fast path from your code straight to the hardware. Next up, stability. And this is a big one, especially with hardware connections. You know how on Windows your COM port can just decide to change every single time you unplug and repug your device? It's chaos. But on Linux, you can use something called udev rules to assign a permanent, sensible name like /dev/mystm32. It's always there, it's always reliable, no more hunting for the right port ever again. And this, oh man, this brilliantly illustrates the third point, control. I mean, have you ever had Windows decide it's time to reboot for an update right in the middle of a really long firmware build? Or an overnight stress test? Of course you have. We all have. Linux puts you in charge. It stays out of your way, and it will never, ever reboot without your explicit permission. Okay. So maybe you're sold on Linux, but Linux isn't just one thing, right? There are tons of different versions or distros out there. So which one is the right one for serious embedded development? So let's just break this down. Look, Ubuntu is fantastic for getting started, and Red Hat is a total stable in corporate IT, but they aren't really optimized for what we need. For serious embedded work, Debian is the engineer's choice, hands down. Its whole philosophy is built around absolute stability, which is exactly what you want. And even better, a lot of our target devices, like the Raspberry Pi, are already built on Debian. That means your development machine can perfectly mirror your production hardware, which just eliminates a whole class of potential bugs right from the start. So, here's the bottom line. If you want a clean, reliable, totally rock-solid foundation for your work, Debian 12, also known as Bookworm, is absolutely the way to go. It gives you a professional-grade environment so you can actually focus on your code, not on fighting with your OS. All right, let's get practical. How do you actually get Linux up and running for hardware development the right way so you can avoid all the common headaches? Now listen up, because this part is critical. Do not use a virtual machine like VirtualBox. I'm serious. The USB connections are notoriously flaky, and a dropped connection right in the middle of a firmware flash, well, it's a nightmare. And cloud servers are out, too, obviously, because you can't physically plug your hardware into a data center. For embedded work, direct hardware access is completely non-negotiable. That means either a dual boot setup or a dedicated machine, period. Before you install anything, you're going to need to make 3 super quick changes in your computer's BIOS. First, switch your SATA mode to AHCI. That's the modern standard that lets Linux see your drives properly. Second, you've got to disable Secure Boot, because that feature can actually stop the installer from loading the drivers it needs. And finally, turn off Windows Fastboot. That'll make sure that when you shut down Windows, the hardware is fully released and ready for another OS to take over. So, if you're going with the dual boot route, the process is actually way more straightforward than you might think. First, just shrink your Windows partition to make some empty space. Then, you create a bootable USB drive. Finally, you just boot from that USB stick and choose the magic Install Alongside Windows option. The installer pretty much handles the rest. It's that simple. Now, if you want to make your life even easier, let's talk about hardware for a second. Picking a machine that's known to just work well with Linux right out of the box will save you from so many potential driver headaches down the road. For years, the gold standard for compatibility has been the Lenovo ThinkPad line. They just work. Simple as that. As an alternative, the Dell XPS Developer Edition actually ships with Linux already on it, so you're basically guaranteed a flawless experience. And hey, if you want to support a Linux-first company, System76 makes some fantastic machines that are built from the ground up specifically for this. And that really brings us to the final and maybe most crucial point. When you use an OS that's designed for this kind of work, it stops feeling like just another piece of software you have to deal with. It actually becomes a collaborative partner in your creative process. It removes barriers and meets you right down at the level of the hardware. So the only question left is the one we started with, really. Are you ready to stop fighting your tools? Are you ready to stop feeling like you're assembling a watch with gloves on and finally start building with the kind of precision and control that your work truly deserves?